All right, we're going to actually do what would be lesson 5 in unit 2, which is on beginning proofs. Now, we have been doing up to this point a lot of worksheets and a lot of marking segments and putting S's and A's on pictures, and we've been going through the 5 ways that you could prove triangles congruent. So at this point, we already know side, side, side. We already know side, angle, side. We already know angle, side, angle. We already know angle, angle, side. And we've even touched on and know about HL, which is in a right triangle. Now what we're going to do is we're going to actually organize our thoughts. We're going to actually work with what we call proofs. Now, two-column proofs, I actually have an example. We're going to look at it. Two-column proofs are a big part of geometry. Now, this class, of course, being integrated, or it has a lot of algebra. It has geometry. It even has probability at the end of it. So this is actually a big part of our geometry. And in geometry, proofs are very important. They're a big part of that curriculum. So we're only going to do a little bit with proofs. And when we do them, we kind of have to know what we're looking at. So an example of a two-column proof is one where it gives you a given statement. Okay, we have a given statement. Notice that the given statement here, this is just an example, so we're not actually going to worry about working this one out. But basically it says that line L is parallel to line M. Okay, well here's line L and here's line M. And we've done these. We should recognize some of these angles. So if those lines are parallel, then I can actually come in here if I was doing this one and I could put those arrows on it. Remember what those arrows mean? Those arrows mean, hey, those are parallel. I want you to notice that in the two-column proof, here is the entire two-column proof. The proof has a given piece of information. This is what they're going to tell us to get us started. They're going to give this information to us. I want you to notice that the given information, the statement of the given information is actually recopied into the first line, the first statement, and it simply repeats, L is parallel to M. Now, when you organize it into a two-column proof, you actually have to state the reason why you know that. Well, the reason why I know that is because, hey, they gave it to me, okay? So my reason number 1 will be given. So you're always going to start with the given, okay? That's going to be my first line. Now, notice that they're actually talking about in step 2, we're going to talk about angles 2 and 6. In step 3, we're going to talk about angles 6 and 7. And we're going to comment on those. We're going to look and see what kind they are. And then we're actually making a connection. Now, this is a proof. Again, it's not one we have to do. But look at the very last part. This is all I want you to pay attention to. I want you to notice that my prove statement says angle 2 is congruent to angle 7. Notice what is the very last line in the proof. The very last line is what it was they told me to prove from the very beginning. So whatever it says in your proof, that's what's going to go at the very end. So you do want to make sure that you start with what's given and you end with what I'm trying to prove. Okay, start with what's given, end with what you're trying to prove. This is what it looks like. Notice that you always have a picture, and we've been looking at pictures for a while. So most every geometry proof is going to have some kind of diagram or picture for you to use. You should have colored markers. Colored pencils would be handy. Highlighters would be good. Anything that has colors, 2 or 3 colors even, so that you can actually sketch on the picture, mark your angles, mark your sides. So that would be helpful. So we have a picture, we have a given statement, we have a proof statement, and then we had a 2-column. Column of statements, column of reasons, okay? The biggest thing about geometry is you cannot assume anything. When you assume things, you kind of sort of sometimes think that things are equal when they're not exactly given to be equal, or even if the lines look like they're perpendicular, maybe they're not truly perpendicular. So unless you have a very good reason, unless it explicitly states it, like it almost has to come right out and just tell it to you, then you can't assume that that's going to be the truth. You have to have a legitimate reason. All right, this is probably a slide that I should copy and provide to you, probably will, but it's not in the packet that we're working at today. Today we actually start with some proofs that are 2-column. Here's the tips. Always begin with the given information. I just showed you that. They're going to have the word given, and then they're going to tell you some information to get you started. That's going to be the first line. Generally, in most every proof I've ever seen, that's the first line. Number 2, do abbreviate or use correct symbols. For example, I would be happy if you just used the triangle symbol to save you from having to write Triangle. Okay? We're also going to abbreviate symbols like perpendicular. Okay? Perpendicular is a long word. So I am perfectly okay if you just make the upside down T symbol. So it is very okay to abbreviate or use symbols. You must have a solid reason to be able to verify parts of your proof. That's what I was talking about. Even if the picture looks like two angles are equal, unless it actually says they are, or unless there's a mark on them already, you cannot assume that they are. Number 4, do write out what the theorem says. We have actually done the vertical angle theorem, but we don't go around saying vertical angle theorem, okay? Vertical angle theorem. We actually go around saying vertical angles are equal, and you can abbreviate. I'm even okay if you abbreviate vertical angles VERT, and you can say angles with the angle symbols are equal. I think it actually probably does say congruent, okay, instead of equal. But if you will say out in as short as simple as ways you want to, that is the easiest thing to do. And you'll see some examples of that as we start. Do mark on the diagrams. Do that. Do that from the very beginning, because we've done that from the time that we started. We put marks and S's and A's and highlighted, the lines and the angles. We did that from the beginning. So that's what I want you to continue doing. Use your picture. The last thing is end with what it is you're trying to prove. So I'm going to begin with the given information, and I'm going to end with what it was I'm trying to prove. So the last line would be what you're trying to prove. It would have your proof statement. Okay? All right. Let's do some. This happens to be a page. I found this from Mrs. E. Teaches Math website. This is from an actual geometry teacher, and this is a list of all the different reasons that students could use in proofs that she has collected. And it was just, of course, this is just a snapshot of something that a student had written in their notebooks, and I thought this was pretty easy. Some of these we won't need to worry about, but several of these we have done. For example, when you go talk about addition property, we've kind of done some segment addition. You're just adding two segments to make a longer segment. Subtraction, multiplication, division, substitution. This is one, though, that we may not have talked about, but you're definitely going to need it. So let me talk a little bit about reflexive property. The reflexive property is when something is equal to itself. Okay, for example, the letter A is equal to, guess what? The letter A itself. The word reflexive property kind of comes from the idea of reflection. If I look in the mirror, my reflection looks exactly like me. Okay? The letter A is exactly the same as letter A. The letter X is exactly the same as letter X. Line segment from A to B, guess what, is the same line segment or is congruent to another line segment that also starts at A to B. Anything can be equal or congruent to itself. That is called the reflexive property. Since we have not talked about that before, I want to make sure that you have a chance to understand. You are going to see this come up. When we were talking about shared sides, and we said the same line goes with like the top triangle, or the same line goes with the top as the bottom triangle because the side was in the middle, that shared side is actually the reflexive property. All right. Do you recognize what are perpendicular lines? Now you have a list of all the vocabulary that we have actually said we were going to use in Unit 2. I actually had you go through and highlight. You're welcome and encouraged to go through that list and to start making sure that you might write down the definition you have, because you have to be able to use those words. Okay? By the time we finished, we're looking at a test in just about 7 days. And in 7 days, you're going to have to make sure that you can use those vocabulary words. We have talked about complementary angles and supplementary angles. We have done angle bisector. We know the definition of what it means to be congruent, or 6 sides equal and 6 angles equal. We have done angle addition. We segment bisector. If you bisect something, you're cutting it into 2 equal parts. So if I have a bisector, and I said BD is the segment, and let's just say point C bisects it, well, then now I know that this segment from B to C is the same measure as it is from C to D. That's a segment bisector. You're going to be using this one too. Definition of midpoint. Midpoint. If I did not say the word bisect, then I could have actually said the word C is a midpoint. That could be a different way of expressing that C is in the middle, which again would say that this left-hand side and this right-hand side would be equal. So sometimes midpoint and bisect accomplish the same thing, even though they're not exactly the same word. All right, we talked about a little bit with segment addition. All right angles are congruent because they all equal 90. Linear pairs are supplementary. Supplementary means they add to what? They add to equal 180. So when we talk about add to equal 180, that is supplementary. Add to equal 180. Vertical angles are congruent. If the lines are parallel, SSI are supplementary, that same side interior. So they're expressed in a different way. If they're parallel, then corresponding angles are equal. If they're parallel, then AI, alternate interior angles, are equal. If they're parallel, alternate exterior angles are congruent. Those are all things we talked about. So these are just some of the reasons that you might come up with. Again, I do want you to know some of those, and reflexive being one of those that I've not really went over with you, but it's not a hard thing. Anything that equals itself is going to be using the reflexive property. All right, we're going to jump in and do one. I'm going to do one or two with you, then I'll let you stop and I'll let you finish the packet, because this is exactly what we're working on in class, and I want anyone who was absent to have a chance to hear and see us go through these examples. All right, first things first. First thing I see is I'm going to read the statement. B is the midpoint of AC. And I'm going to go to my picture, because I want to go to my picture, and it says of AC. So if I go to AC, well, right here is from A all the way to C. And then it says B is the midpoint. So I bet you if I'm using midpoint, I bet you the definition is going to come into play. Well, if B is in the middle, does that mean that this side, okay, and this side are the same length? Yes, they are. So since I actually already have one mark here, I'm going to actually put 2 marks here and 2 marks here. So now I have marked those sides from the very first part. The second part says AD is congruent to CD. A to D, well, A to D is right here and they've already got a mark, and C to D is right here and they've already got a mark. So they've actually already marked some of the information that they've given to me. Okay, I actually made my own marks because they actually just said, hey, it's the midpoint, and as a consequence of that, I know that the midpoint means that I'm going to have 2 segments the same. Okay, let's take a look at the very first line in the proof. The first statement says D is the midpoint of AC, AD congruent to DCD. Do you see that recopied anywhere else? Is that the same as what was given? Okay, so by what reason do I know that information? Well, notice that we are going to be using, I'm not going to throw you to the wolves, so to speak, as I did, my geometry teacher did. I'm actually going to give you a word bank. So these are all the phrases and words that you're going to use to fill in the reasons in this 2-column proof. Now, how did I know that information? Well, it was given. We're going to start every proof with the given information. Notice given is an answer. So number 1, the reason I know that information is because, hey, they gave it to me. It's given. Number 2, how do I know that A to B, okay, that's right here that I marked in red. How do I know that A to B and C to B are the same? Well, I've marked it. I put 2 marks on it already. But how did I know that this segment and this segment were the same? How did I know that? Well, do you remember earlier when I circled this word midpoint? We knew that B was in the middle. Well, if B's in the middle, then that means that the 2 sides are the same. So that word midpoint is something I used, and after I used it, then I was able to make these 2 segments with lines on them. All right, let's look at our word bank and see which one of these reasons tell me that these 2 segments are congruent. Which one of these reasons? Is it definition of a right triangle? Have we said anything about a right triangle? No. Well, we're not ready to do HL because that's a proof of how you can prove things. Perpendicular lines form right angles. I ain't said nothing about perpendicular in this problem. I'm going to say no, I don't need that. Definition of midpoint. In the statement just above it, we had the word midpoint, and from that midpoint, I was able to actually put my mark. So, I actually used the word midpoint to know what it means. And yes, I guess I did use the definition of midpoint. So we do have a word bank. Please note all the phrases or words will be used, but now we've used the first two. Given has been used, and definition of midpoint has been used. Okay, let's go to statement number 3. DB is congruent to DB. Whoa, okay, DB falls right in the middle, and it doesn't have a mark on it. Right there is DB. DB is congruent to DB. Well, what did we just say? The same thing congruent to itself is called, like looking in a mirror? Well, it turns out we've been calling that all along. We've been calling that a shared side or a shared line, and it is. But now when I actually say it in a proof, I'm saying DB is congruent to DB. Again, how do you know that? Well, it's like the same thing is equal to itself. If I look in the mirror, my reflection looks just like me. That's reflexive property. It's the first time that you've had to use the phrase reflexive property. Okay, it's reflexive. Everybody feel good about that? Hopefully you do. Because notice it says D to B equals D to B. Same thing equals the same thing. Now when I get to statement 4, I'm at the very last part of my proof. And notice what am I trying to do? The key thing that I'm trying to do in number 4 is I see it says triangle. I see it says triangle, and I say congruent. So apparently I'm trying to prove that one triangle is congruent to another triangle. So it looks like I'm trying to prove ABD triangle, or ADB, is congruent to CDB. So the triangle on the left is congruent to the triangle on the right, but how do I know that? Well, I do have some things to look at. It could be HL, or it could be SSS. Those look like the two I would probably choose from, because those are one of the 5 ways that we've already learned to prove triangles congruent. And I think if we come back up here and we mark it, like we've been doing before, how do we mark them? This is an S, this is an S, and the third one is a third S. So number 4 reason is going to be side, side, side. So that was the one I needed. That's your first 2-column proof. It's supposed to be a logical sequence of steps that would take you from what's given, okay, to what we were trying to prove. And it probably takes you through logical steps. Sometimes the steps are a little tedious, but with a word bank, we're trying to take baby steps to introduce you to beginning proofs. Number 2. All right, I'm going to mark my given information. AD is congruent to CB. Okay, A to D is right here. C to B is right here. So those 2 segments are congruent, which means they are the same size. They already have the mark on the screen for me, so that's good. Okay. The next part says AD is parallel. So we got to know our symbols, so that symbol means parallel. Parallel means they're going to run side by side and never touch. They actually have that marked for me. Do you see these big heavy black arrows that are right here? Okay, I'm kind of darkening them in with this green marker, but those heavy black arrows are already there, and because they're already there, I know that that means that they are parallel. All right, so let's just go ahead to statement number 1. Where does this information come from? Did it come from here? And so how did we know that? Like, where did that come from? Well, it was, yep, you got it. It's given, okay? Most every proof that we'll do is going to start with a given information, okay? Notice that it says it was given, okay? Now, this is where you definitely want to have those colored markers, colored pencils, colored ink pens, highlighters available, because now what I'm going to do is I'm going to actually have to mark on my picture, and I'm going to use a red marker, and it says this symbol is an angle, okay? So I'm going to be marking an angle. The angle starts at A, goes to D, ends at B. I'm going to use it I'm going to create the angle at D. So I'm going to start at A, go to D, end at B. And the angle is actually formed right here at D. So I'm going to put my arc mark across the angle that's formed right there at D. So I've marked my first angle. Now let's mark the other angle. Start at C, go to B, end at D. And I'm going to start my angle. My angle is going to be at B. Start at C, go to B, go to end at D. The angle is formed right there at the middle letter. The middle letter is angle B. Now it says that those two angles are congruent. How do I know that they're congruent? Okay, we did trace them with a color. Do you notice any shape on parallel lines that we practiced in class? Z shape. Oh, they're Z shaped. Okay, let's see what our thing said. Well, we know we've already used our given information, so I'll mark that one. Would it be alternate interior angles are congruent? Oh, alternate interior angles. Yes, they are alternate interior angles. Since they're Z-shaped angles, those Z-shaped angles are what I ended up with. If I trace my red lines, there's a Z-shaped angle. So this is the answer. Alternate interior angles are congruent. All right, good enough. Alternate interior angles are congruent. Okay. Number 3. So 2 statements down, 2 to go. Statement 3. DB is congruent to, guess what? Itself. DB. DB goes right across the center, and of course it's a shared line. We talked about shared lines for a couple of days now. That shared line still gives me the same thing. The line segment goes from D to B in one triangle is the same line segment from D to B in another triangle. So if DB is equal to itself, which one of our statements says that something is equal to itself? I don't think it's definition of midpoint. That didn't use the word midpoint. I'm not ready for SAS or ASA just yet. And I don't think those are vertical angles, so they must be reflexive property. Remember when I said you're going to use this one a lot? It kind of seems silly to have to actually say that something is equal to its own self, but that's what you got to do. You got to be very blunt. Spell it out for whoever. All right, last statement. I am trying to prove that a triangle ADB is congruent to triangle CBD. Trying to prove congruent. There are 5 ways to do that. Go back up to your picture, mark your S's and A's, and see what you end up with. Now, you only need to mark one triangle, so I'm going to actually ignore the bottom half, and I'm going to mark the top half. This is a side, this is an angle, this is a side. So by what method are the 2 triangles congruent? Answer: side, angle, side. Again, having a word bank down there kind of gives you some direction, kind of gives you some choices, things that you might consider. Again, it's a logical sequence of things to go through. Number 3. This will be the last one I'll do with you, and after we do this one together, we already talked about midpoint. Did we talk about midpoint? I think we have. I'm going to skip 3, and I'm going to skip 4. I think I'm going to do 5 with you. And when we finish 5, I'm going to let you give it a go on your own. Okay. All right, number 5. First things first, do you know what this symbol is? Got to know your symbols. Got to know your vocabulary. That stands for what? Perpendicular. So what it's saying is 2 line segments are perpendicular to each other. Now, do you know what perpendicular means? From P to R, which comes across here, is perpendicular to the line segment that goes from S to Q. So those 2 are perpendicular. Now, what does the definition of perpendicular mean? Might be something you might want to pause the video and go look it up. You had that in Math 1, but if it's not coming to mind, look it up. Okay. Did you find out that when things are perpendicular to each other, they form what? They form right angles. Okay. They don't just cross any old way. They cross at exactly 90 degrees and they form right angles. That is what perpendicular means. Okay. So I've got that much information. And I'm going to go ahead and do statement number 1. Okay. Statement number 1. How do we know that R is perpendicular to SQ? Wow. Well, guess what? I didn't have to dream it up. I didn't have to figure it out on my own. It is what? It's in that given statement. So number one is given. So I have given down here, and I'm going to use my given. Number two, angle PRQ. Notice it's got the angle symbol right here. It's angle PRQ. And then angle PRS are what? Right angles. Angle PRQ and PRS are right angles. And they've got my marks there and there because that's what perpendicular says. So I need to know the reason. Now, they didn't say, remember how you have to say it out explicitly? They did not say in the given information, oh, PRQ and PRS are right angles. But is that something we would know because they gave us perpendicular? It should be. It should be a logical conclusion. Oh, I guess if they are perpendicular, my angles should be right angles, correct? Because that's pretty much what we mean. Now, let's go through our definitions. This is a 6-step proof. Which one of our choices in our word bank down here is going to be the best reason why we would be able to go from perpendicular to right angles? Okay. All right, I got the first one. Perpendicular lines form right angles. This one says right angles, and this one says what? Right angles, and this one says parallel perpendicular lines, and guess what we had just above it? Do you see how that's a logical conclusion from the first statement that leads into the second statement? And that's my reason. Perpendicular lines form, and I'm going to abbreviate right, RT, angle symbol, angles. I hope that you see that. That's kind of what this is. Geometry is a lot of logic. It's a lot of just reasoning. That's stuff that just progresses. Once I know this, I go to this. Once I find this information, I go to something else. All right, now let's go to number 3. First thing I noticed in number 3 is I got the same letters, PRQ, PRQ, but I don't have the same symbol in the front. What is that symbol? That is a triangle symbol, okay? So now it's saying triangle PRQ. That means I'm going to connect all the 3 points and make a triangle. And triangle PRS are what? Right triangles. Well, what do you have to have a right triangle? You got to have a right angle or a 90-degree angle inside that triangle, and then you can call it, hey, it's a right triangle. So it kind of seems like all these were repeating ourselves, but I didn't. Notice that up here, I was actually talking about angles. Down here, I'm actually talking about triangles. There is a logic to this. It almost seems like you're spelling stuff out, but there is a logic. Okay, let's just go. Is that given? No. It has to say it exactly in the given. It didn't say nothing about triangles in the given. Is it reflexive? No. That's got to be the same thing equal to the same thing. Is it HL? I'm not ready for that. Not ready for that. Is it the definition of a right triangle? That looks pretty good. Let's check it out. Definition of midpoint. Nah, they didn't use the word midpoint ever and probably don't need that. Alternate interior angles. I ain't got nothing this time looks anything like a Z. Okay, and vertical angles. Well, I don't have anything that looks like an X. So I guess right triangle. Okay, notice it says right triangle, and up here we're trying to say that they are what? Right triangles. So if you've got a right angle in it, it is definitely a right triangle. Okay, definition of right triangle. Let's keep going. Seems like a lot. I'm sorry I'm taking too long. I'm just trying to explain as I go. PQ is congruent to PS. PQ, oh, it's already got a mark on it. PS, that's already got a mark on it. How did we already get that marked? Oh, look right here. That was actually in my original given statement. But I didn't need it until now, or they didn't use it in their proof until now. But this statement was actually given at the very beginning. So what they did is they put one part, the first part of the given information was used at the very beginning, step 1. But they waited to use the second part until they got to step 4. But I do notice down here, I actually have a second place where I have a given statement. So that means I am going to need to use given twice. Does everybody understand why 1 and 4 are both given? I hope that you do. All they did is you had 2 different statements. We split it into 2 different steps. Number 5, PR congruent to PR. What do you know? Something congruent to itself. Sure. PR in the middle is congruent to PR because PR is in the top triangle and PR is also part of the bottom triangle. So PR is congruent to itself. What do you call it again when something is congruent to itself? It looks exactly like itself. That is reflexive. Okay, hopefully that's getting easier to recognize. Finally, in our last statement, we've been doing this for a couple of days. We're trying to prove that triangle PRQ, which is the bottom triangle, is congruent to the bottom triangle or top triangle PRS. How can we prove that those two are congruent? Well, we've went through all of these things, and we've talked about right angles, and we've talked about PQ and PS, and we've talked about PR. We've got enough information that we've got a lot of marks in our picture. Let's go mark our picture. Here's my right angle. What's the longest side across from that right angle? I think that's called the hypotenuse. And what do you know? I have a mark on it, so I do have the H. So this might be hypotenuse leg. Do I have a mark on the leg? Yep, here's another side, and that is considered a leg, so sure enough, I do have an L. So number 6, this is proven congruent by the HL theorem. All right, that is our third example of a proof. The rest of the packet, I will say though, for day 1, I am not asking you to do number 6. Don't cross it out where you can't read it. But this one is a little bit different than the other 7. So I do want you just to skip 6 for now, and then we'll do the 6 tomorrow. Okay.